Hey Algebra 1 Advanced students, we are doing another day of notes today. So this is the 5th day of notes for chapter 1A, and we are looking at opposites, absolute value, and reciprocal. So I know I went a little over my time yesterday with my 15-minute lesson, so I'm going to try to keep this one a little quicker. So first we're going to look at opposites. So the definition for opposites is two numbers which are the same distance from the origin. So the origin is where we would find 0 on a number line. So if I think of a number line, and let's say this is 0. So if I'm over here at 2, the opposite would just be 2 units in the other direction. Well, of course we know that would be -2. Okay? So this is just a fancy way of saying change the sign. If you're looking at a positive number, the opposite is negative. If you're looking at a negative number, the opposite is positive. So here's our first example. So sometimes you'll see people write the opposite as just adding a negative. So a negative always produces the opposite. So if I want the opposite of -6 or a -6, well, we know that 2 negatives make a positive, so 6 would be my answer here. All right, what is the opposite of 8? So if we're looking at a positive number and we want the opposite, we just make it a negative. So -8 would be the opposite of 8. Okay, number 3, what is the opposite of -1500? Well, again, opposite, you just change the sign, it would be +1500. All right, next topic for today is absolute value. So here's the formal definition for absolute value. It's the distance away from 0 on a number line. Distance is never negative. So normally in class, I make a real number line with students. So I pick a student and I'm like, hey, you're 0. I'm gonna have them hold up a little 0 sign. And then to the right of that student, I'll put a person right here. And I'm like, hey, you're 5. And then down here, I say, hey, you're -5. And then we talk about distance. Well, which number's farther from the 0? Well, they're the same. They're both 5 spaces away from 0 on the number line. So that distance away is the absolute value. Okay, and distance cannot be negative. Just because you're in the negative direction, your distance away is still positive. I like to think of this too when you're driving a car. Like I live in Columbia. I drove to Belleville West today to record this lesson. I don't even know how far it is. I probably should have looked. Let's say it's 15 miles. So I drove 15 miles to get here. That's the distance I traveled. When I go home, I'm still traveling 15 miles. Distance, whether you're going east, west, north, south, we always talk about the distance away from something in a positive way. That's the same thing for absolute value. It just can't be negative because it stands for a distance. So basically, you just drop the negative sign. And we show absolute value using these bars. So right here, I want the absolute value of -16. But to make it a little trickier, there's a negative out front too. So you do the absolute value first. So the absolute value of -16 would be +16. But to make it a little trickier, we snuck a negative in here. So the final answer is negative. A lot of students make the mistake that they say, oh, a negative and a negative is a positive. It doesn't work with absolute value. You have to take care of the absolute value first. Then you deal with the sign out front. All right, and now we're going to look at sort of how absolute value will come into play when we're doing order of operations. So we did order of operations yesterday. I know that I have to start with parentheses. So I'm going to start with my innermost parentheses here and just sort of work my way out. So if I have a -10, that would become a +10. So let me just rewrite this. Okay. All right, so normally now I handled my innermost parentheses already, right? I still have a grouping symbol here, but it's acting in a multiplication manner. I take care of absolute value with grouping symbols because you don't want to get into anything else until you take care of this absolute value. So I am going to do the absolute value of -40 first. Now, I am going to multiply whatever that result is by 5 once I get to the multiplying and dividing step. So instead of writing the bars again and just keep going in this absolute value circle, I'm going to change them to parentheses just so I can show myself that, hey, I need to multiply, okay? So the absolute value of -40 is +40. Okay, and now inside any grouping symbols, there's nothing else I need to worry about. So I can go ahead and multiply and divide from left to right. I'm actually going to do these on the same line because they're not affecting each other. There's a plus sign in the middle. So I will start with 5 times 40, so that's 200. And then we can write this in two ways. We can do plus, and then I know this is going to be a -60, so you could write plus -60 if you want. I'm actually just going to change it to a -60 just to save myself the trouble. All right, and then my next step is going to be 200 minus 60, so that'll be 140. All right, halfway through our examples for today, and I'm under 7 minutes. I'm feeling good about this pace. Hopefully you guys are as well. Again, if you're needing more time to process, you just go ahead and pause the video, take as much time as you need, rewind, and come back when you're ready. All right, next thing we're going to look at are reciprocals. So reciprocals are two numbers whose product is 0. Whoa, I can't even talk today. Reciprocal is a fancy way of saying flip it. Okay, so we're going to flip the numerator and the denominator. That's the reciprocal. In order to find the reciprocal, though, you need a numerator and a denominator. So if we have an improper fraction, we need to make it, or if we have a mixed number, we need to make an improper fraction first before we flip it. All right, so what is the reciprocal of 5 2/9? Normally, reciprocal, real easy, you just flip it. So let's pretend for a second that, and don't write this in your notebooks, just watch. If we had just the 2/9 part, and I said, hey, find the reciprocal, you're just gonna flip it, okay? Boom, you'd be done. It doesn't work like that in mixed numbers, though, because we're not taking into account that 5. So we want to first make it improper, then we're going to flip it. Okay, so we're going to multiply these. So 5 times 9, well, that's 45. And then you're going to add the 2, which gives me 47. So 47 over 9. And then we're going to flip it. It's going to be 9 over 47. You always want to check with fractions that your answer is simplified. In this case it is, so we are good to go. All right, the next one, what's the reciprocal of -3.2? So we don't even have a fraction here. So there's a couple ways you can approach this. I'll make it a mixed number first just to show people that. So if I have a -3 before the decimal, that's the whole number. And then I know this is the tenths place. So I can put that number over 10. Now, clearly that is a fraction that can be simplified. So we can go ahead and simplify that. So the whole number is still -3. 2 over 10 is actually 1 over 5. Now we can make it a mixed number. Notice I'm using equal signs because I'm not changing the value at all. When I take the reciprocal, I can't use an equal sign because reciprocals are not equal to one another. So if you're wondering about notation, that's why I'm doing that here. So 5 times 3, that's 15, plus the 1, that's 16. So negative 16 over 5, or negative 16 fifths. Now I can do the actual reciprocal, so I'm going to flip it. And it's going to be negative 5/16. I always like to keep my negative with my numerator. If you want to just keep it with the 16 when you flip it, that's fine too. But there we go. Now, reciprocals are something that's super easy to check if you go back to that original definition. So I'm just going to make myself a little note. Let's check what we're doing. So the definition of reciprocal is when you multiply them, you get a positive 1. So let's do in a calculator, negative 3.2 times negative 5/16. So I'm going to type it in right here. I have a calculator next to me. The negative sign, 3.2 times, I'm not sure if I need to use parentheses. Let's go without. So I'm going to do negative 5 and then the ABC button and then the 16. Yep, it worked. It gives me a 1. So if you're unsure if you did reciprocals right, just multiply the original problem and what you're saying the reciprocal is and see if you get a 1. And if you do, it checks out. Okay? Again, there's a lot of different ways to go from here to here. This is just one of the ways, just the way that I think is the most user-friendly way. So if you have different work from here to here, that's completely fine. We have one more example that I want to look at. And it involves reciprocals. So we looked at fractions earlier this week, and I said that we are just adding, subtracting, and multiplying. Well, that's not always the case. We do divide fractions. So when we divide fractions, I want you to think of these 3 letters, K, C, F. And a lot of you know this from last year. This stands for keep, change, flip. And flip, we now know, is reciprocal, okay? So this is what we just talked about. But when we divide fractions for the second one, we're going to flip it. So you keep the first one, you change the sign in the middle from division to multiplication, and then you flip the fraction. So we are only going to get one example in on this, and then we'll talk about it more in the future. So keep, change, flip. So I'm going to keep this guy. So 25/8. Keep. I'm going to change this symbol from division to multiplication, and then I'm going to flip this guy in the back. Okay. Now, like when we were multiplying fractions, if you can cross simplify, you can here. You cannot cross simplify up here. You cannot cross simplify over a division symbol. You got to change it to multiplication. Then you can simplify, okay? So these guys jump out at me first. They're both even numbers. They're actually both divisible by 4. So I'm going to go straight to dividing them both by 4. So that's going to give me 2 and 5. Now, when you simplify this way, they're both divisible by 5. So that's going to give me 5 and 7. And then I multiply across the top. 5 times 5 is 25. Across your denominators, and you get a 14. We do not need to make that a mixed number. Improper fractions are completely fine. So that is it for today's lesson. I'm right at 14 minutes, so awesome. I think I'll stay under 15 once I wrap this up. So we are done with new material for this week. You have a few homework assignments from the week you need to make sure you're submitting to me through Google Classroom. Tomorrow we are just going to go over all those assignments. We're going to do our Friday finisher, and then you guys should be good to go for the weekend. I will see you then. Bye.